Okay, so on this question, I'm going to, they're asking us to figure out the orders of these various shapes and the angles of rotation that they have. So okay, so what is this? What is the order? The order equals the number of times you may turn it, you may rotate it, the number of times you may rotate it so that it goes onto itself perfectly. Oops, sorry. There we go. So that's what order is. Order is the number of times you may rotate it so that it goes perfectly onto itself. So let's talk about a square. Okay, so if you come down, let's look at a square. So here's a square. So how many times can you rotate the square as you go around? How many times? Well, I think you know, right? Like this part that's straight up in the middle, you could rotate it so that that goes over here. And then you could rotate it so it goes right here. And you could rotate it so it goes there and then back on the top. There's actually, or the order for the square is 4, meaning there's 4 positions the square could be in. And it would be right back onto itself, right? You could make this dot at the top, any of those 4 positions. That dot that's at the very top could be rotated to the left, bottom, right, or top. There's 4 different positions. Order 4 for the square. And let me actually show you that as we well, here let's do one more. So the order is 4. And then that tells you, so there's 4 different positions as you rotate the square. 1, 2, 3, 4 different positions, and it'll come right back onto itself, right back onto itself. And what that means for the angle, you take 360 and you divide by the 4, the order, and that tells you 90 degrees is the first angle of rotation. So let me show you now on the actual tool. Here we go. So cover that up. Okay, there you are. You're seeing the question on my screen. If you go down to the bottom, down here, this is what you'll see. There's a tool down here. As you move your mouse, you can make that square bigger or smaller. Now we want that square, so we want to rotate that. Watch if I grab this angle. Let me make it a little bigger for us. There we go. I'm going to grab this little tool. Watch, I'm rotating. See that rotating? Another one. See it rotating, 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 rotating. Bonk. It's right back onto itself. Well, right there at 90 degrees. It's fitting right back onto itself. That's the first angle of rotation where it fits into it. Then you keep going. It's rotating further, rotating further, rotating further. 180. There's the second time. Keep going. 270. There's the third time, and of course, all the way around. There's the fourth time, right? So let's go back. So there's original. So there it is at 90. That's the first time it goes back into itself. 180 the second time, and 270 the third time, and 360 the fourth time. So there's 4 times it fits back onto itself. Let's try the next one. Come over here. See this tool? Turn off that and click on the rectangle. If you have trouble finding that, I realized that you can get it like this. Watch. If you go down here, you move this bar over here, and you turn off this right here. It allows you to see these controls better. So anyway, I'm doing rectangle now. So let me go down, let me move back. So I'm doing rectangle. Okay, let's go back to 0 degrees for the rectangle. So there's the rectangle. How far do you have to rotate the rectangle? You're rotating, rotating, rotating. 90, that's not right onto itself. Keep going, boom, right there. At 180 degrees, it's back onto itself. and then keep going. It's rotating, rotating, and then 360. So at 180 and 360, it's come back unto itself. 180 and 360. So that's twice, right? That order is twice, 2 times. You know, as you go from 0 to 360, 2 times it comes back unto itself. We right here once at 180 and once again at 360. So the order will be 2 on that. So the order is 2, and the angle is 180 because that's the first angle. This one was 4, order 4, 90. Now, how about a rhombus? Well, come down here and let's turn this off and let's do a rhombus. How far do you have to rotate that rhombus to get it to come back unto itself? Let's rotate it. Boom, 180 and 360. So it's the same thing. It's 2, isn't it? The order's 2, and it's 180 degrees. How about the parallelogram? So let's turn off the rhombus, turn on the parallelogram. Yeah, I don't know why it's way over there. There we go. There's the parallelogram. So let's rotate it. How far till it comes back into itself? Boom, 180. Keep going, 360. So halfway and all the way, 180 and 360. So the order's 2. 2 times it went back onto itself. 180 degrees is the first angle of rotation. How about an arrowhead? Let's go down the list here. An arrowhead. There's the arrowhead, right? I don't know why it's getting way over there. So it's rotated. Wait, did it work? It was up. I'm rotating, 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 rotating. There's 180. It's not unto itself, is it? Keep going, keep going, keep going. Boom. Only once. The order was only once. And the degrees is 360. Right? It took 360 degrees for it to come back onto itself. The order's only once. There's only one time as you rotate it from 0 to 360 that it came back onto itself. How about an isosceles triangle? Let's click on that. Okay, here we have an isosceles. Isosceles means 2 sides. 2 sides are equal. Let's rotate it. Is it not unto itself yet? Not unto itself. Not till you go all the way to 360 does it come back onto itself. So only one time as we went around 360. Next one is going to be the equilateral triangle. And so let's go back to the beginning here. Let's rotate the equilateral. Now, equilateral means all 3 sides are the same. Rotate, rotate, rotate. Boom. It's back into itself at, what's that, at 120, right there. Perfectly back into itself at 120 degrees, right? When that top went down to the left, which is 1/3 of the way around. Keep rotating, keep rotating, keep rotating. Boom, second time at another one, 2240. And then third time, always 360. So it did it 3 times. One more time. Let's see it again. As you're rotating, rotating, rotating. Once at 120, twice at 240, and third time at 360. So 3 times for the equilateral triangle. And the first angle was 120, right? Because that's 360 divided by 3. See how you just take 360 divided by these answers and you get the first angle of rotation? Let's try the next one, a regular pentagon. What's a regular pentagon? Click. There it is. It's a perfect 5-sided shape. So let's rotate it. How far do you have to go? Boom. It's back into itself at what? What is that? At, I can't tell exactly. It's going to be whatever 360 divided by 5 is 72 degrees. There it is. Right unto itself at 72. Keep rotating. And then again at another 72, 144. And then third time. And fourth time. And fifth time. So 5 times as we went around. So 5 times, you take 360 divided by 5, you get 72 degrees. Does that make sense? 5 times around, and then a hexagon, any regular hexagon, any guesses, 6 sides, it's going to be 6 times around, isn't it? 6 times around. Let me bring it up here. We'll start rotating it. And boom, there's the first one at 60. Second time, third time, fourth time, fifth time, sixth time, right? Does it at 60, and then again at 120, and etc. Does it 6 times, 6 sides, 6 times, and 360 divided by 6, 60 degrees. You see, you just take 360 divided by the order. Last one, a regular octagon. There it is. You guessed it, 8 sides, and boom. There, make it bigger. There we go. Let's try it again. So it's rotating, rotating, boom, right into itself, huh? Once, and now what was that first one? Rotating, rotating, boom, right there at, I can't tell what it is. It is, I don't know, let's see. And boom, right there. It's like is it 45? Yeah, it's at 45. Yeah, perfect. There it is, 45 degrees. At 45, at 90, it did it again. Another 4, 3, 4, 5, 6, 7, 8. 8 times as we go around, of course, and divide by 8, 45. 360 divided by 8, 45 degrees. So there we go. That's how we do that problem.